what we're doing is we are using, we've just done a starter where we've just had to go at some multiple choice questions. So let's just go through this together. So we're starting off with the multiple choice questions, which you will have in your practice exam. Your practice exam is a combination of paper 1 and 2. It's basically amounts to 2 hours. That's obviously next week. You've all received your timetables in your revision booklets last term. So let's just go through this. So we're looking for the groups of the periodic table that can form compounds containing covalent bonds. So what's the clue here? What's the clue, Zane? They're non-metals. They're covalent, so it's got to be non-metals. So which groups are we looking for here? The ones on the right side, yeah? So if you're looking on your periodic table, it tells you it tells you that you're looking for which groups? 5, 6, 7, 0. Yes, 5, 6, 7 and 0. So let's have a quick double check of that on our periodic table. If I can just quickly pull that out. It should be at the back of my textbook here. No, it's not the wrong textbook. So which one is it? Anyone?
C.
It's going to be C, isn't it? Yeah? It could be C. Is that right? You all right with that? I'm not all right with it. Why would we not get covalent bonds for a group 0 element? They're noble, yeah? It's inert. So we definitely won't have any bonds. So it's got to be D. Okay? Right, so we did use that little bit of problem solving. We had 2 possible answers because both of these are on the right side of the periodic table. They're both non-metal groups. But we remember that group 0 doesn't form bonds. They're inert because the electron shell is full. That outer electron shell is full. So then we look for the formula for nitric acid. This is something you might know. If you don't know, we can deduce. We can actually get down to 50-50. It's a bit like playing Who Wants to Be a Millionaire. We can get down to 50-50 by eliminating obvious wrong answers. So our clue is nitric acid. What element do you think is going to feature in nitric acid? Nitrogen. So which 2 do you think we can eliminate straight away? Yeah, because they don't contain nitrogen. So highly likely that it's not, and we know that that's actually salt, and you might know that that's sulfuric acid. So nitric acid is actually B. Okay. So number 19.
What's D?
D. I can't remember the name of it. Ammonia. It's ammonia. Remember we talked about the Haber process last term. So which type of substance undergoes electrolysis? So we're looking to try and remember what we know about electrolysis. Electrolysis requires a current to flow, doesn't it? So we're looking for something with mobile ions. Okay? So a molten covalent compound, it's covalent. Is that going to have ions in it? Possibly, but we're not sure about that. I mean, if it was ionic, yeah. Solid ionic compounds, they've got ions, but they can't flow. Gaseous covalent compounds, but as they're compounds, as they're compounds, and they're covalent, then the charge is neutral. Aqueous solutions of ionic compounds, part D.
What does aqueous mean?
Aqueous means it's dissolved in water. Okay, so remember that if you don't know it, you might want to write that down for yourselves. Okay, sit with us a paper, please. It's a paper. Let's get a paper over to you. You've arrived a little bit late. Come and sit over here, please. Thank you. Right, let's move on. We are recording this lesson. So, the next one, question 20. Which row shows what happens during an endothermic reaction? So, endothermic. We've got exothermic and endothermic. We always think of exothermic means exit. So it gives out energy. So if it's giving out energy when it reacts, endothermic must be taking in energy. So what's going to happen first of all to the mixture? If it's endothermic,
it increases, right? Because it's taking in.
Let's have a think. Endothermic means means you have to take energy in, so the temperature would decrease, wouldn't it? Okay, that's all right. There's no such thing as cheating. You can use your books. I've said that already. So, let's think. If it's endothermic, we know it's taking energy from the surroundings, because energy has to come from it. So if it's taking energy from the surroundings, it's going to be colder, isn't it?
Or are we not talking about the inside or the outside?
So we take energy from the surroundings. So the surroundings has to actually take energy in to make it when it reacts. So it'll cool it down. Yeah? And the way it cools down is by the mixture, first of all, temperature decreasing. So it's A. Okay? I think, judging by some of the reactions, that may be something you might want to go back into your notes and into your revision guides and into your textbooks and really sort of recap. Okay? So, number 21. Carbon reacts with carbon dioxide at high temperatures. So, we've got to think very carefully here. If we're thinking carefully, we've got carbon, we've got a word equation. Carbon and carbon dioxide forms carbon monoxide. So what's happened here? What's happened chemically, Zane?
Does the carbon get reduced? No.
Well, let's think. What's happened to the carbon here?
It gets reduced.
No.
Let's think.
Oxidized.
Okay, we've got some confusion. So let's use some problem solving. One way to solve the problem is to look in detail at what this is. If we think about it in terms of a basic formula, we know carbon dioxide is CO2, and that's CO. Okay? So if we were to balance it, I know it doesn't ask us to balance it, but it helps us to do this. Look. Yeah? So now you've got 2 carbon, 2 oxygen. Here we've got 2 carbon and 2 oxygen. So it's balanced now. So what's happened to one of the oxygen atoms here? It's been lost. Where's it gone? Where's it gone?
2 carbon.
It's gone to the carbon, isn't it? Yeah? So that has actually effectively gone into that carbon. So if we gain oxygen, if a substance, if we gain oxygen, is that reduction or oxidation? It's oxidation. So the carbon is oxidized. So we're already knowing it's one of these two. If we lose oxygen, then that would be the opposite, wouldn't it? And the opposite to, that's it, it's oxidized. So the carbon is oxidized, the carbon dioxide is reduced. So it's C. Okay? Right. Number 24. Which row describes a transition element? Now, I'll set you a whole homework on this. Okay? So first of all, what do we know about transition elements? They're the metals in the middle, aren't they? Okay? So they're coloured. They form coloured compounds.
They're catalysts.
They can be catalysts. So even if we don't know, if we're not sure about density, B's the answer because it's the only one that's got them both right. Right. Here's an interesting one. Which substance does not react with chlorine? Now, we've got to think very, very carefully. Think very, very carefully. What are we going to say here? We've got hydrogen. We've got, what's this element? Get your periodic tables out. Get your periodic tables out. Okay, I'll give you a minute. Get your books out and get your periodic tables out. Have a look at it. I'll pause the recording for a second while you do.